Today, inshallah, we're going to continue on our topic of cybersecurity. We're going to talk about how to find what is the meaning of security vulnerability, and basically, give some examples of some software vulnerabilities that you can find in some applications. So basically, security vulnerabilities are any kind of software or hardware. It's not just software, by the way. Defect that can be exploited by a malicious user or malicious users. Okay, so first of all, exploit as a term, this is a very very common expression that people use in this context, is a term used to describe a program written to take advantage of a known vulnerability. Okay, so basically, vulnerability meaning that you have a problem in the software or the operating system. Somebody wrote a program that actually takes advantage of such vulnerability, basically. So basically, it works on such vulnerability to gain access to the system. But actually, as such, is not a problem. But the attack is basically when you basically take this exploit and basically start using it. So it's the act of using an exploit against a vulnerability. So basically, you start with an exploit and then basically use that exploit to perform the act of attack, okay? The goal of attack, of course, is to gain access to the system, the data, to gain access to, either to the system to use it as a bot or something like that, or use or basically access the data, or basically use some specific resources that such system might have, okay? So basically, any attack will have one of these goals, basically. So you have software vulnerabilities that might result from errors in operating system or application code. Every now and then you hear that a problem was discovered in, for example, Windows operating system, okay? And that the Microsoft is working on a fix or an update, okay? So basically, the time between the discovery of such vulnerability and the availability of the fix is basically an opportunity for the hackers to basically take advantage of such vulnerability, basically, okay? Same thing for application code. So basically, if you have apps, if you have basically any smartphone, you'll find that basically every now and then you will have to install some updates to your applications. Such updates are not just for performance, by the way. Many of them are for security, basically, because some of the maybe somebody discovered a vulnerability. So basically, the software, the updated software, basically takes care of such vulnerability, basically. So the goal of software updates is to stay current and avoid exploitation of vulnerabilities, basically. So it's very important to install updates in a timely manner, okay? So as I was saying, that there's a time between the vulnerability is discovered, okay? And then there is a fix. There is a time in between for the hackers to work on an exploit and use it properly, okay? The problem is after the fix is made available, not every computer is basically installs this fix in a timely manner. So basically, even people actually are talking about problems in the Windows operating system that were discovered maybe in 2007 or 2008, something like that. And people are still using such vulnerabilities now to basically hack into computers. So some very old computers or some very careless users, maybe these users are in public places, or where basically they don't really feel that it's their responsibility to update the computers or anything like that. So basically, many computers stay without the fix and basically keep that, extend the time for the hackers to take advantage of such vulnerability. So it's very important to update the system regularly. Whenever a problem appears and a fix is made available, we have to install it right away. Another problem that might be a little bit difficult to imagine even, that there might be hardware vulnerabilities also. So basically some hardwares have design flaws, okay? now basically the hardware are not like a dumb piece of equipment that doesn't have any intelligence. No, basically there are some hardware components that are very much intelligent, and basically they can communicate on their own without software, basically. So basically the boundary between hardware and software is becoming very vague right now. It's very blurred. So basically you might have a vulnerability in the hardware design that would allow the user or allow the hacker to basically take advantage of it and basically gain access to the system. So basically such hardware vulnerabilities are usually specific to device models, and basically they are not really generally exploited using random compromising attempts, meaning that for software vulnerabilities, basically you can basically try to exploit the system using a variety of ways. Basically, if you don't know anything about the system, you can still try several techniques, and one of them might work. For the hardware vulnerabilities to work, or basically to take advantage of a hardware vulnerability, you have to know specifically which device model has this vulnerability and how to take advantage of it. So basically the attacks on hardware vulnerabilities are very much targeted, meaning that you're targeting that specific model and basically you're taking advantage of it. Okay, so basically there's a difference between software vulnerabilities in that perspective. From the point of view of software security vulnerabilities, there are basically several techniques, several vulnerabilities that might exist. For example, buffer overflow. Basically, some of these actually are kind of problems that you might face while you're programming, for example. If you're using like Visual C or Visual Basic or whatever, you might end up having some of these errors actually while you're trying to debug your code, or basically trying to develop a code for something. Such problems might appear, but the tricky ones are basically the ones that appear after you deploy the software. So basically you design your software, it's working perfectly as you designed it, okay? But some malicious users uses basically inputs in a particular way, or a malicious input somehow, and basically takes advantage of a problem in your software, okay, that you didn't notice. Okay, for example, the buffer overflow problem means that the data are written beyond the limits of a buffer allocated to an application. Usually for modern operating systems, it allows for multitasking. It allows for multiple applications to be opened at the same time. And it keeps switching between these applications to give you the sense that they are basically executed in parallel, but they are not in parallel, basically. So basically, usually for each program or each application, either on your phone or your computer or whatever, it allocates a certain amount of memory for that application to work. Okay, it has boundaries. And basically it has other apps basically in the same memory. So if this application basically uses more memory that is the one that is allocated for it, then it might actually overwrite another application. When this happens, actually, some apps, some malicious apps can actually overwrite another app with a malicious code, so that it can gain access through that other app to basically gain access to the system. Okay, so basically by changing the data beyond the boundaries of a buffer, application accesses memory allocated to other processes and can lead to system crash, data compromise, or provide escalation of privilege. Escalation of privilege is a very important term that you need to understand. Basically, when you're running an application on Windows, okay, you're basically running this application as a user. This application might not have the privilege to overwrite operating system files, for example. Okay, so basically, if this app has this buffer overflow problem, and basically you have an OS application, one of the applications that the operating system is using, okay, is very close by in memory. So basically, if this goes beyond the limits of the buffer allocated to it and writes into the operating system, then basically whatever code is written here will run as the operating system. And basically it has what's called escalation of privilege. Escalation of privilege, instead of having the privileges of a user, you're now having the privileges of an administrator. So basically you have an escalation. Basically you raise the privilege from a user to administrator. And when you are an administrator, you can create accounts, you can give passwords, you can change passwords, you can delete secure data, you can do anything you want, which is really dangerous. So this is one problem that might happen. Another problem is non-validated inputs. Non-validated input where the data coming into the program could have malicious content. Let me give you an example for this. Actually, this is a very interesting example. One version of Samsung Galaxy phones, people actually created a background image. Basically, if you want to set the background of the phone, you can just point to an image file and it would load it and put it in the basically in the background of the phone. It's very simple. We all do that. Okay, so people created a file, an image file that is extremely large. Okay, that basically it's not in itself large. Basically, for an image, usually when you open an image, it has a header and it has the data of the image itself. Okay, in this header you have information about the size of the image. Okay, so basically you get that information from here, and usually the program allocates enough memory, you know, as per the size of the image, so that you can load the image from here into the memory. Okay, so what people did was very simple. They came to that header and put an extremely large size here. So the image itself is not really large, but the header here had, instead of having, for example, 1000 by 1000, you put like 1 million by 1 million. Very large number. And basically, whenever the operating system tries to open that file, basically it tries to allocate a memory that is much larger than what is available on the phone. So basically, it would just crash. And the problem is it keeps crashing. Whenever when it crashes, it starts from the beginning, and basically, whenever it goes back, you know, whenever it boots, it goes back to the same point when it's trying to open that file to put it in the background. Because basically, whenever the phone opens up, it gets that file because it was set to be the background file, and basically tries again to open it. So basically, it would keep crashing all the time. It's an extremely trivial, trick that people did actually, but it showed how dangerous, softwares can be when you don't validate the input. Okay, you have to validate the input. If you read a certain file, basically you have to make sure that the size of the file fits into your memory. If not, then you would know that the program should automatically, decline to open it, or basically give you an error message. Otherwise, basically, it would end up being a problem like this. Okay, so this is a very simple hack that actually, basically even the software from a large company like Samsung basically was fed into basically. So basically, you force, when you actually don't validate inputs, you force the program to behave in unintended way. Okay, for example, allocation of a buffer of incorrect or unexpected size. Okay, so this is a big problem. Another problem you might have is if you basically try to open a buffer that has a negative value. Basically, softwares are as smart as you made them, and otherwise they are as stupid as it gets, basically. If you don't tell the program exactly what to do with whatever input it gets, it basically does really dumb things. Okay, so it's extremely important to think ahead and make sure that whatever program you're writing basically takes care of everything that is expected to be basically expected to happen to that software or introduced to that software in practical situations. One of the very important things that are new, actually, kind of new, okay, which is something called race conditions. Race conditions became, one of the important vulnerabilities when basically people introduced multi-core processors. Multi-core processors, instead of having only one processor and everything happens sequentially, now you have actually real parallel programming. You have codes running on different processors, and basically you're combining the data from all of them to speed up the execution of a certain program. Imagine that you are trying to multiply an image by 2. Okay? You basically divide the image into sections and basically try to allocate or basically try to divide these operations between the processors you have. The problem with race conditions is that two processors are trying to access the same location in memory. So, for example, you're updating a certain location, and this location actually is used by another processor to do another thing. So basically, you updated that location, but the other processor actually took the old value and used it instead of the new value, and basically this can cause a problem. Or you're trying to do certain operations and update a certain location at the same time. For example, let me give you a particular example because this is kind of important. Basically, imagine that you have a million numbers, okay? And basically, you're trying to do the summation of all these million numbers, okay? So basically, you create a variable called sum, and basically divide these numbers between multiple processors. Processor 1, 2, so on, and okay. So all of them are trying to do what? They take the value of sum, and then they add one of the numbers, and basically take the summation into, put it back into sum. Okay. So if they are trying to do that at the same time, then basically if you divide these numbers between the processors, then basically there is a set of numbers for each one of the processors. Okay. Now you take the value of sum, and basically you add a number and basically do that, and basically the other processor is doing the same thing. They took the initial value of sum and they add another number, and basically they want to write it again to sum. The problem is when you start here, you took a certain value for the sum, basically. Basically here they are the same. And then these two processors are trying to do the same operation. So basically at least definitely one of them will do that operation faster somehow, okay? So basically they are not gonna be able to write the result at the same time here. So what's gonna happen? Basically one of them is going to overwrite some, and then the other one will overwrite some after that. The problem is basically you overwrote, you basically had that sum overwritten here, okay? And then the other one will overwrite it again by the summation here. The problem is that the initial sum that you started with here is exactly like the one here. So basically the sum that was here, that was written first, is not used here to add that additional number. So basically whatever you overwrite here will basically ignore that number, because it's gonna be basically the last one that will be written will have the basic override the other ones. So the race conditions are basically when multiple processors are trying to write into the same memory location. And basically if this is not done right, then you might lose data, you might get wrong results, you might get all kinds of problems. Imagine that you're using a computer to speed up things, and basically it does speed up things. It made things, at least maybe 5, 6, 10 times faster, but the result is incorrect. Do you want to have that? Of course not. Nobody wants to have that. You want to
good result. You want to have the correct result in less time. You don't want to have any result or incorrect result in less time. It doesn't make sense. So basically, people started using some kind of like flags or semaphores or whatever, where basically when I'm using some, then this is allocated only to this particular process or this particular processor. When I'm done with it, then others can start using it, whether it's reading or writing. So basically, this way you access that particular location and basically use it and basically let others use it after that. So basically, it's a little bit different. And basically, you have to take care of that. Otherwise, you will get incorrect results. And the race conditions is basically because several processes or several processors are trying to access the same memory location. And basically, only one of them will be basically the one that will overwrite it. And basically, when it does that, it might actually make the other operations incorrect. So this is very important to take care of, basically. Let's go back. So the race conditions are the output of an event depends on the ordered or timed outputs. So basically, it depends on which processor started. Basically, the output will change according to that, which is incorrect. It shouldn't be like that. Okay. So when you have multi-processor computer accessing or changing the same memory location by different processors, this would happen actually. So basically, this is extremely dangerous. You don't want to have that. You don't. Whenever you're using multi-processor environment, you should make sure to avoid these race conditions. Of course, the first thing to come to mind when you think about vulnerability is weaknesses in security practices, like improper authentication, authorization, and encryption. Okay, so basically, if you use a very weak encryption, then it would be cracked very easily by the hackers, and basically, it's as if it's not there. Authorization and authentication, basically, you make sure that this user is who he seems to be. Basically, he claims to be X, then you make sure that he's X. Authorization, you make sure that this user has the authority or the privilege to access certain data or certain applications in your system. Okay, so as a piece of advice, it's a very important advice. Developers should not attempt to create their own security algorithms. Okay, it doesn't make sense for you to create an encryption for your own use. Okay, because it will likely introduce vulnerabilities and should definitely use security libraries that were already created, tested, and verified. So whenever you create a code, it has a cycle of basically discovery of vulnerabilities. So basically, you introduce it, people use it for a while, then start testing it. They might find vulnerabilities. Then when that happens, you start creating a fix for such vulnerabilities, and then you introduce another version, and this version is tested again, and more vulnerabilities are discovered, and more fixes are applied, and so on until a stable version is reached. So basically, most of the encryption libraries that are available in the commercial use actually have been tested by so many people. And people know exactly, that they are very stable, first of all, and basically they are very strong. And basically, up to the time of the application of such libraries, basically they are basically they don't have any vulnerabilities. They might discover vulnerabilities in the future, but actually, you have a much better chance to use such libraries than to start a new software from scratch and start the testing process either by yourself or the community. Basically, it takes time to do that. So never try to do such things, either authentication or encryption, by yourself. Try to always use libraries that are mature, that are tested by the community, that have good security reports, so that you don't have vulnerabilities in your system. There is also the problem of access control. Basically, this is actually one of the things that we talked about in EHR. We have to actually, this is by HIPAA, we have to actually make sure of that. Okay, so basically this is a process of controlling who does what. Okay, many security vulnerabilities are created by the improper use of the access controls, ranging from managing physical access to equipment to dictating who has access to resources and what can be done with it. For example, actually this goes beyond the software basically. Okay, access control is basically either from the software itself, where the software can access resources, and such resources might be misused or basically used in an improper way. Okay, or access data, that doesn't belong to the person who's accessing that data. Okay, it might also mean that you have access to the physical system. So basically, you have the server room basically without a lock, and people can walk into that room without any authentication or any problem at all, basically. So basically, whenever you have a physical access to the system, you have a lot of things that you can do actually. And as we will say, actually, if you have a physical access to the computer, you can do whatever you want. Okay, it's extremely dangerous to allow people to have physical access. Okay, so one of the important things is to make sure that the access control is maintained for the software users and basically physically in the environment where the server room is present. So basically, this is what we were talking about. Read this statement carefully and basically try to understand it. Nearly all access controls and security practice can be overcome if the attacker has physical access to the target equipment. Basically, every practice that we talked about and every practice we're even going to talk about, if you have all kinds of anti-malware, if you have all kinds of, whatever, encryption, whatever, if you have physical access to the hardware, if you have the hard drive, you can actually take that hard drive and read the data off of it, okay? And even for the encryption, basically you can actually try several techniques to crack that encryption. If you have the hardware, if you have the data, which is extremely, it's extremely difficult to have that. Basically, if you're trying to avoid data loss, basically people can take away these hard drives that have the data and just go away. Basically, you just steal it. Okay, so you're not going to lose it by getting these data erased or something like that. No, you're going to lose the physical drive that has the data, which is extremely difficult to basically to compensate for or to recover from. Okay, so basically, for example, no matter what you set a file's permission to, the operating system cannot prevent someone from bypassing the operating system and reading the data directly off the disk. Okay, so basically, many people actually use, maybe all of you probably, if you check your hard drive, some of the advanced computers, they might have encryption for the hard drive. Okay, so basically, if you don't have that encryption for the data on the hard drive, then the permissions or the whatever you see as security on your system depends on the operating system. So the operating system looks at the user, and if the user is a regular user or basically a guest or whatever, then he doesn't have access to certain files that are assigned as administrators' data, for example. Okay, so basically you allow the user to access whatever the operating system allows him to access. Okay, if he's an administrator, then he can access such data without any problem. But if you have the hard drive, then you can read whatever you want from the hard drive. You don't have the operating system to prevent you from reading the data, which is extremely difficult actually to prevent. Okay, so basically you bypass all the security in the operating system and all the anti-malware and whatever by just having the physical device and reading that physical device using another computer. To protect the machine and the data it contains, physical access must be restricted. This is very important. You should never allow physical access to your servers. And basically, in addition to that, you use encryption techniques to protect the data from being stolen or corrupted. Okay, so basically, basically, if you have the data at rest, what they call it, the data at rest, you have the data that is moving, which is on the network, and you have data at rest. The data at rest, whatever data you have stored in a database or whatever, you have to use encryption. And such encryption actually will make the data here, if the person gets that drive, it's going to be extremely difficult for them to access the data, because that encryption might be really difficult to crack. Okay, so use an encryption, a good encryption, okay, to prevent people from basically gaining access to the data using the physical drives. This is very important. But the most important thing, it's like the prevention before mitigation, basically. Prevention meaning that you prevent people from gaining physical access in the first place. Okay, mitigation is basically whenever people gain physical access and cause damage, you try to mitigate, you try to solve that problem or try to recover. Okay, preventing physical access in the first place is much better than trying to recover. Now we're going to talk about the different kinds of malicious software. Okay, some of these things you already heard about, but some of them might actually be interesting to know and basically know the difference between them and the other types. So first of all, malicious software, some people, or basically the term for it is malware. It's malicious software. Okay, so just take ware and mal, and basically it's malware. So malware is any code that can be used to steal data, bypass access control, or cause harm or compromise to a system. The first kind of malware is what's called spyware. Spyware is designed to track and spy on the user, which is like activity trackers, keystroke collection, and data capture. I don't want to alarm you or anything like that, but actually this was used extensively by universities to track the students while taking exams, okay, during the pandemic, okay? I'm not sure if you heard about that, but actually this, a lot of softwares, but these are actually like legal softwares, but they buy it and basically they install on the student's computer so that they actually can know exactly what the student is doing. So basically the examiner can see, for example, what the student is looking at, okay? They can track the keystrokes of that student. They can actually, if he's using a network, they can actually know exactly what he's sending and receiving on that network. So extremely difficult. Basically, when talking about spyware, it's not basically the same thing that universities were using. It's like something that happens by hackers, basically. It's for regular users, not the students taking exams. Basically, they are basically regular users, and basically the spyware got installed from a website or a malicious link or whatever, and basically it allows the hacker to follow what that user is doing. The most dangerous thing is basically the keystroke collection. Of course, activity is very important, but keystroke collection is very dangerous because it allows the hacker to know the passwords, and this is extremely difficult to basically recover from. If somebody knows your password, then he will have access to your system without any problem. So sometimes this spyware can modify security settings and often bundles itself with legitimate software or what's called Trojan horses. Trojan horses, we're going to talk about them in a little bit. Okay, so basically you might find some spyware bundled with a legitimate software. So for example, if somebody tells you that I have a copy of MATLAB, it's a legal copy of MATLAB, okay, but actually when you try to use that copy, it might actually have that spyware installed on it. So usually try to as much as you can, try to use softwares from a legitimate source. Okay, it's better to get it from the vendor itself rather than getting that from a CD bought from somewhere or from a friend or whatever. Okay, so this is very important. Spyware is very important. The dangerous thing about spyware is that it spies on you without you knowing. Okay, so it's not like something you can know or something like that. Basically, it can spy on you for a lot of time, basically, a long time before you discover that your system got hacked. Okay, so this is extremely dangerous, basically. A lighter version is what's called adware. Okay, we all saw that. Okay, some of the softwares actually are installed, but they tell you that there is a free version, but this free version is ad supported. Ad supported, meaning that you're not going to pay anything, but actually, in order for us to make some money, we'll just show you some advertisements while you're using that software. Okay. This is not as malicious as this one here, but actually some of them are designed to basically be spyware. So basically, as long as you have that adware, if it's only for advertisement, then it's not a problem. But usually, or in some cases, in particular situations, some people actually use that adware to deliver spyware. So basically, you never know. And as I will tell you, if the software on your computer is tracking you, how are you going to know that? It's very difficult, very, very difficult to know. So basically, be aware that adware is not always okay. Okay, make sure that you're getting that the software with adware from a trusted source. Okay. The problematic issues that start from bots, basically, or robot computers. Okay, malware designed to automatically perform action, and that action is usually made online. So basically, malicious bots are botnets where several computers are infected with bots programmed to quietly wait for commands provided by an attacker. So basically, in such bots, there's a software or a malicious software. Basically, it gets installed on the system either from a website or a malicious website that you visited, or a message that that has an attachment with infected with a malicious software or whatever. But at the end, your computer gets infected and becomes a bot. Becoming a bot is extremely dangerous because most of the time that bot will be basically sleeping. Basically, it's not doing anything. It is just waiting. Okay, so basically it's like a sleeping cell. Basically, it's waiting for a command from the master of that botnet, and basically whenever that command comes, it can do a lot of things. It can do a lot of harm. Basically, it can basically made to attack a certain website. Okay, it can be made to basically spy on the network that you are working within. So basically, if you're working from the university network, for example, the bot will try to basically identify other computers or communicate with other computers on the network to spread the malicious software, and basically made other computers on the same network as bots, as part of the botnet. Okay, so basically this is very dangerous, of course. We all heard about ransomware, which is a malware designed to hold the computer system or the data it contains captive, or basically as hostage until a payment is made. So basically ransomware is also a malware basically can be spread by downloading a file or basically using some software vulnerability on the system that the hackers exploit. And basically, whenever it gains access to the system, it starts quietly encrypting the data on the system. Okay, and basically, when you have an encryption, and we're going to talk about encryption in some more details, later on in this course. Basically, you have a key. Okay. And this key, basically, without the key, we cannot decrypt. Okay, so you encrypt using a key, and then in order to decrypt or recover the data back to its original form, you have to use the same key so that you can basically reverse the operation of encryption. Okay, so basically it does that with a key only known to the hacker. Okay, or basically it can sometimes take advantage of some specific system vulnerability to lock down the system. So basically you're trying to log in, you cannot log in. Okay, the system won't allow you to log in. So basically it encrypted the system, or basically use a vulnerability and logged you out of your system. So basically you have no access to your system. Okay, and the hacker gives you a message that you contact me in this way and send me this much money or whatever. Usually they use the cryptocurrency so that it's difficult to track. And at the end, basically, you pay a ransom in order for your computer to basically be recovered. Okay, this is extremely dangerous, and the ransomware attacks are extremely. You basically it can stop, large corporations actually, had problems with ransomware. Hospitals had problems with ransomware. Healthcare institutions had problems with ransomware during the pandemic, which is extremely difficult. I actually sent you one of the articles that was talking about something like that. Basically, they were talking about attacks that happened in 2021, and basically you'll see that not just the computers, organizations and vaccine delivery centers and even healthcare personnel actually were attacked during that year. Basically. So basically, it's very important to be extremely, careful when you're trying to download softwares or basically opening links or going to a certain site that might not be safe. So basically, ransomware is very dangerous. Basically. Of course, we all heard about virus. Basically, whenever we talk about malware, the first thing that comes to mind is virus, basically. The virus is a malicious executable code that is attached to other executable legitimate programs. So basically, you're trying to install, for example, Adobe Acrobat, for example, okay? You didn't download it from the manufacturer, from Adobe. You basically, one of your friends said, I have a copy of it, I'll give it to you, I'll send it to you, okay? And basically this copy was infected. So when you try to execute it, basically it's gonna install that software or install that virus on your computer, okay? So basically most viruses require end user activation and can activate at a specific time or date. So basically, meaning that basically you have to execute that code. Sometimes it's the program that has the virus can activate by itself at a specific time or date. It can be programmed to do that. So basically it can actually be installed in one of the operating system files that actually have a timed execution, which is very dangerous. Viruses can be destructive, such as those that modify or delete data. This was very common, actually. Usually, I remember my days at Cairo University, basically, I avoided completely taking any data from my students because basically, the environment, basically the ecosystem at Cairo University, the student ecosystem is basically, I think, all kinds of viruses are there, basically. So people are not careful. They don't have a good hygiene when they deal with programs. They basically, it's very easy for them. If the computer gets infected, they just format it and basically reinstall the operating system from the start. And usually the operating systems are even not original. So basically it might actually have the virus already there from the start. So it was extremely difficult to get a file from a student because basically a lot of viruses were there. And such viruses, basically, whenever they gain access to a system, they would basically delete files and sometimes they modify files so that it's very difficult to open them. Okay, so basically they can be really destructive. Sometimes they can actually corrupt the operating system itself. Okay, so basically, as I was telling you, sometimes you had to reformat the hard disk in order for you to be able to install the operating system and basically get a clean version of your computer. Viruses can also be programmed to mutate to avoid detection. Okay, this is basically what you know as signatures. Whenever you have an antivirus software, each every now and then it tells you that it needs to download updates, okay, or new signatures of the viruses. Basically, the signatures are basically parts of the code. Do you know that this code, basically, this is like the machine code of that virus, And basically, whenever it's present in a piece of code, basically, you know that it's a part of a virus. Basically, this code is a virus. So basically, it can try to modify such signatures so it can avoid detection. So basically, you do something called mutation. So basically, the programmers can actually put different things in different places and basically keep rotating things so that they can avoid detection, which is very, you have to actually be very careful about that. Most viruses are now spread by USB drives, optical disks, network shares sometimes, and emails. Okay, so USB drives are the replacement for floppy disks that were basically the source of most viruses at the beginning of this malicious software invention. Okay, of course, if you have a CD or a DVD, the same thing. If you have a network share, meaning that you're sharing files with other people, then this might be a source for such viruses. Basic email, of course, if you have an attachment that is malicious, it might actually, if you open it, it might actually cause a problem. Basically, it can install the virus. So the virus, by definition, is an executable code, basically. As we're going to see, some other malicious software, they do not need to be executed. They actually execute by themselves. They use the services that are run normally in the operating system to basically get installed and spread to other computers. But for the viruses, you have to actually do something to install a virus. Okay, it's not going to come by itself. Okay, we're going to talk about something called worm. Worm is like a Duda. Okay, worm is basically it spreads by itself. It doesn't need you to do anything. There was actually a problem in I think 2003, where actually one of the vulnerabilities in Windows operating system in the network part of the Windows operating system, it allowed a worm to basically spread all over the world. And the problem of this worm was basically it created more traffic on networks than necessary. So basically it would double or triple the network traffic. And basically at certain times, actually this worm threatened to stop the internet because there was so much traffic, and this traffic is basically is not transferring any data. Basically, it's just, you know, this worm spreading itself. Okay, so basically here you have to spread it by sharing files, basically, and such files must be executable in order for a virus to be installed. We come now to the Trojan horse. Of course, the Trojan horse is basically taken from the very old story about the you know, the Greek. Basically, there was like a very strong city actually that had walls. And basically, there was an army that tried to invade that city. And basically, they could not. Basically, they tried all kinds of warfare, basically, and they could not penetrate the walls because the walls were really well built. And basically, the soldiers inside that city were able to defend the city, you know, from behind those walls. So what they did was to basically have, basically made a horse that was basically a hollow horse, basically. And basically this horse was very large, and they put some soldiers inside that horse, and basically they put it on the doors of the city, and basically said that it's a present to the king of that city. Okay, so basically they opened the doors and they entered. They basically took that horse inside. And at night, basically, the soldiers came out of this horse and opened the gates, and the army went in and was able to basically bypass the walls, and basically they were able to invade that city. Okay, so basically, this is used here. This expression is used here for malware that carries out malicious operations under the guise of desired operation. So basically, you have something that looks benign, looks really harmless, okay? But actually, it has a bad side. It has it hides something inside that actually does whatever malware wants to do. Okay. So, for example, you have malicious code exploits the privileges of user at runs it, And basically, it can be found in regular files like image files, like audio files, or games, or whatever. For example, for image files, you might find a file called, for example, image.jpg, okay, for example, okay. This file seems very harmless. This is just an image file, okay? But actually, sometimes this file actually is not a JPEG file. So basically, you know, sometimes the operating system hides the extension of the file, okay? So basically, it might be this way, but actually it has an extension of executable. So basically, try to click on this image to open it. It would basically execute that software and basically install the virus on your computer, okay? So basically, it's just be careful of such image files and audio files and games and things of that sort that you can download from the internet. Sometimes, basically, it actually looks like something that is harmless, but actually it has an executable part that actually runs whenever you try to open that file. Okay. So basically, this is very important. What I was saying before about the worms here, this is the definition of the worms: malicious code that replicate themselves by independently exploiting vulnerabilities in networks. So they replicate themselves. So if there is a worm somewhere, it can replicate itself. It relies on problems in the network or network equipment, okay? So for example, it can be the operating system, the part that deals with networks in the operating system, or it can be the hardware of the network itself, the routers, the switches, things of that sort. We're going to talk about these things, inshallah, in the next topic, okay? So basically, this is actually malware that spreads itself, that basically replicates itself on other computers without doing anything, okay? So basically, whereas virus requires host program to run, worms can run by themselves and slow down networks. This is basically the main problem here. Other than the initial infection of host, worm is able to spread very quickly over the network, okay? So basically, as I remember, actually it was in the US at that time, I remember that maybe 1/3 of the computers in the world were actually infected by the worm that took advantage of the Windows operating system vulnerability. Okay, so basically, imagine 1/3 of the computer. Every 3 computers in the world, one of them would be infected. And basically, if the fix didn't come out as you know as quickly as it did, actually, maybe all the computers in the world would have that worm, basically. Worms share similar patterns and enabling vulnerability. Basically, this is the essential feature that it uses to spread, okay? A way to propagate themselves, and they all contain a payload. Payload meaning that a harmful code, basically. Payload meaning that it's like a package, okay? Like if you have like a truck or something like that, if you have a load on that truck, basically this is the payload, okay? So basically, if you have a worm, you can make it actually to carry a virus and spread that virus in other computers. Okay, and basically, worms are responsible for some of the most devastating attacks on the internet. For example, what's called Code Red work in 2001. One of the attacks that happened on the internet, basically the spreading of worms in most of the computers in the world, actually in 2001. Basically, one of the things that you're going to do in the project for this part is to report on one of the attacks. I'm going to give a list of attacks and basically assign each one of you one of these attacks. And you're going to present these attacks, basically you write a report on them and present them, and basically your work will be to explain that whatever happened in that attack to other students. Okay, one of them would be this one. Other more advanced attacks was called man-in-the-middle attack, MID-M. Okay, basically man-in-the-middle means that now for example, you're accessing your bank. Okay, and basically whenever you access your bank, you think that it's only you and the bank website or the bank server, communicating with each other. If you have a certain malicious software, some malicious softwares actually allow the attacker to take control over a device without the user's knowledge and basically make itself in the middle between the user and the bank. So basically, the software basically will be in the middle. The virus or the malware will be in the middle. Okay, so basically you can see anything you do and basically can take whatever you have here and modify it and send it to the bank, which is extremely dangerous, actually. Okay, so basically with that access, attackers can intercept and capture user information before relaying it to its intended destination. Okay, so basically you can get some information from here and basically send it somewhere else. Okay, so basically it's not necessarily your bank. Basically, you can be somebody working in the Department of Defense, for example, or working at a university, and basically he's communicating confidential information with his university or the department or whatever, and basically attackers can actually get that information or modify that information and basically cause a problem. Many malwares exist to provide attackers with mid-M capabilities, and this is why they used to steal financial information in particular. Okay, financial information in particular is probably the most widely spread application of this attack, basically. Okay, so basically, such malwares are actually like put in websites, put in attachments on emails that are sent as spam to many people, and basically whoever opens that spam message and opens that attachment, basically he will be basically hacked, and basically his computer will have malware, and if he tries to access his bank, basically all the information will be accessed by the hacker. Okay. Somebody might think that now we have a multi-factor authentication. Basically, whenever you access your bank, it asks you for a code that is sent to your phone, right? This is what happens now. Now, it's not enough to just have access to the link between you and the computer. You actually have to have also access to the mobile information. So basically, you can combine this one with this one to create a very devastating attack. So man in the mobile, it's exactly the same, man in the mobile. So basically you have also malware, but it's in the mobile phone. So basically it's a variation of MIT-M used to take control over a mobile device. When infected, mobile device can be instructed to exfiltrate user-sensitive information and send it to the attacker. So basically it can filtrate, or exfiltrate is basically select the information that is sensitive or usable by the attacker, and basically it would get that information and send it to the hacker. Okay, so basically you can use that. One of the viruses, actually one of the examples called Zeus, it allows the attacker quietly to capture the two-step verification SMS messages sent to users. So basically if you have the same user with MIT-M and you also get the two-step verification, then from here you'll get the username and password. And here you'll get the SMS message that that is used for verification. And basically you have all access, you have all the access in the world actually to that bank account. So basically the hacker can basically access your bank account, okay, or the bank account of the victim, and basically he can do whatever he wants. He can transfer money, he can buy stuff, he can change the password, he can do whatever he wants, which is extremely difficult. Basically, whenever that happens, it's extremely difficult to defend against. Okay, so please be careful with installing applications that you don't know much about. Be sure that whatever mobile device or whatever computer you have, you should have proper anti-malware installed so that you can detect such events, because it's very difficult to recover from when such things happen. Some of the malicious software types are called scareware. I actually get a lot of that, and for some reason, I'm not sure why, but actually, one time actually I was about to click the message that had that scareware. Basically, I ordered something from Amazon, and basically I got a message from Amazon for some reason, okay, saying that my payment didn't go through. And basically, in order for the order to go through, I have to basically enter the credit card information again. Okay. So basically, I saw it on my phone and basically said that, okay, whenever I usually don't like to open links on my phone. So basically, I said that whenever I go to my computer, I will check that. Okay. And when I did that, actually, I noticed that the message was not sent from Amazon. Okay. It was sent from somewhere else. And I checked the link. Basically, if you hover over the link, basically, if this is the link here, if I just get the mouse over it, don't click it, just come over it, you will see the link. Okay, the link will appear. So basically, you would know where that link leads to. Okay, never open a link before actually hovering over it and basically checking the link to make sure that it actually points to a legitimate website. So basically, if it's Amazon, then it has to be an Amazon website. Okay, this is extremely important. Okay, so scareware basically is something that would give you the impression that something is urgent. Okay, it scares you. Okay, when you are scared, you tend to act quickly without thinking. Okay, so basically you're trying to, or this malware is designed to persuade users to take a specific action based on fear. Okay, for example, it tells you that your credit card was stolen or that your account was hacked. Immediate action is needed, something like that. Okay, it basically plays on your fears. Okay, so basically it forges a pop-up window that resembles operating system dialog, for example, and conveys a forged message stating that the system is at risk. Okay, actually this happens if you go to some websites actually might actually have such things. Basically, it would give you a pop-up window. And this pop-up window would tell you that there is a problem with your system, and it looks very legitimate. Actually, it looks like the Windows legitimate pop-up windows. Okay, and tells you to basically and basically it has an OK button, for example, just to confirm that you saw that message. When you click that OK, it basically installs the malicious software in your computer. Okay, so please make sure that whenever you are browsing, whenever you're working on your email or whatever, make sure that don't click anything before checking carefully about where that is coming from. And if it's a pop-up window, make sure that it's a legitimate window. Don't click on any windows that look suspicious, because actually, whenever you do that, you might actually install a virus on your computer. Okay, so basically, this is very important. So basically, whenever the scareware gives you that window, if the user agrees and clears the mentioned program to execute, his or her system will be infected with malware. Okay, scareware is very widely spread. Basically, you basically, if you didn't receive such messages, I would be surprised. Basically, the most dangerous type of virus or malware is rootkit. Okay, it's malware designed to modify operating system to create backdoors. What is the meaning of a backdoor? Basically, operating systems are designed to be secure, meaning that it has a certain basically it checks on the how the network, the ports, what's called ports of the system, so that basically nobody can access the system in an illegal way. Okay, in this particular malware, attackers basically infect the operating system itself. Whenever you infect the operating system itself, you just add a file to the operating system, and basically this file becomes an integrated part of the operating system. Then it has the privilege of the operating system. This is the highest privilege you can get on a system. And whenever you have that, you can actually instruct that malware to open a backdoor. For example, it opens a certain port, and it allows a malicious user to enter through that backdoor. Okay, so basically, attackers can then use that backdoor to access the computer system remotely. Okay, and basically most rootkits actually take advantage of software vulnerabilities to perform privilege escalation. And then basically, whenever they do that, they modify the system files and insert the rootkit into the operating system. Okay? And the very dangerous thing about them is that they can modify system forensics. If you want to learn about a virus, okay, if you know, basically if there is a virus, basically you check on the virus through the forensics. Basic forensics meaning that if you have certain log files on the system, or basically if you have the network interactions, for example, it's present somewhere. Basically, there are many logs in Windows that basically write everything that happens in the operating system. If you have a rootkit, it has the privilege of accessing and modifying such log files. Basically, it can change the log files to delete the activities that it made. So basically, if a forensic analyst or basically an expert comes to check the system, it would basically, you would not find anything on the system. You would not find an evidence of a rootkit being present on the system. So basically, it does malicious actions, and it is very good in hiding such actions. Okay, so basically, they are very hard to detect. Okay, whenever a computer is diagnosed with a rootkit, it must be wiped out completely and reinstalled. Wiped out, it's not just you're going to reinstall Windows, you actually have to format the hard disk. Okay, sometimes you have to do that in order for the clean install to run without any problems, because it might have some parts of it still present on the hard drive, and basically it can basically reinfect the system again. Okay, so basically this is the most dangerous form of malware. I think we're not going to have much time to go over the symptoms of malware. So inshallah, next time we're going to start from the symptoms of malware and basically learn about how to, without even having an antivirus, just detect very common signs of having something wrong with a computer system. Do you have any questions? Okay, inshallah, I already put a part in the grade center about the bonus. So far, 2 students sent me the certificates. Please check the bonus part of the grades you have. And if I did not record your certificate, the bonus, the +5 point bonus for your certificate about the cybersecurity course, please send it to me again, okay? Thank you. Any questions again? Okay. So inshallah, I'll see you next time, inshallah. Salam.